Okay, what if we could predict whether a mental health treatment will actually work for someone before they even start it? It sounds like science fiction, right? Well, today, we're diving into some absolutely groundbreaking research that might just pull psychiatry out of the era of guesswork and into a future of precise, data-driven care. Let's get right into it.
All right, here's our roadmap. First, we'll talk about the big challenge that psychiatry's been facing. Then, we'll open a brand new window into the brain with some really cool technology. We're going to see how that tech is decoding the mysteries of psychosis and depression. And finally, we'll wrap up by looking at what all this means for the future of truly personalized mental health care. So, first up, let's set the stage with the central problem this whole field of research is trying to solve, that long and, often really frustrating search for the right treatment.
For millions of people, this isn't just some abstract question. It's their reality. You start a new medication, and then you have to wait for weeks, sometimes even months, just to see if it helps. And if it doesn't, well, you have to start that whole process all over again with something new. It can be an exhausting, seemingly endless cycle. And this really gets to the heart of the problem. In other areas of medicine, doctors have objective tests, things like blood work or CT scans, but historically, psychiatry has had to rely on this trial and error approach. It's all guided by how a patient says they're feeling, which of course is super important, but it doesn't have that hard biological data to help predict which treatment is going to work for which person's unique brain.
But what if we could get that objective data? Well, that brings us to some new technology that gives us exactly that, a direct window into how a person's brain is actually functioning in real time.
I love this analogy because it makes a really complex technology called TMS EEG so easy to understand. The first part, TMS, that's transcranial magnetic stimulation. That's the tap. The second part, EEG, or electroencephalography, is the device that's listening for the brain's unique electrical echo in response to that tap. It's just a brilliant and totally non-invasive way to measure what's going on in there.
So here's how it actually works, broken down into 3 pretty simple steps. First, the TMS machine delivers a totally safe, targeted magnetic pulse to a specific part of the brain. Second, an EEG cap, which is just full of sensors, records the chain reaction of electrical activity that follows. That's the echo. And finally, scientists analyze that echo, which gives them direct measurements of key brain properties, like its complexity and its plasticity.
So, how is this actually being used? Well, let's start with psychosis. In this case, the key thing researchers were looking at was something called brain complexity. Now, brain complexity might sound super technical, but the idea is actually pretty intuitive. It's really just about the richness of the brain's conversation with itself. A brain with high complexity is generating all sorts of intricate signals, which allows different parts of the brain to communicate well. And that is the absolute foundation for coherent, organized thoughts. This slide just illustrates the difference perfectly. A healthy, high-complexity brain is like a full orchestra playing this beautiful, intricate symphony. But in a state of psychosis, it becomes more like just a couple of instruments playing simple, repetitive notes that are totally disconnected from each other. That richness is gone, and that's what leads to the disorganized thoughts that are so characteristic of the condition. And here it is, the crucial discovery. The researchers found that as patients responded to their antipsychotic medication, the echo in their brain literally became more complex. That disorganized noise started to turn back into a symphony. And this is a huge deal. It's the first objective biological marker we've ever had that shows a treatment for psychosis is actually working on a neural level. Okay, so that's psychosis. Now let's switch gears and see how this same technology applies to another condition, depression. But here the focus shifts away from complexity to a different property of the brain, its ability to change, which is a concept known as plasticity.
Brain plasticity is honestly one of the most incredible concepts in all of neuroscience. It's just the brain's basic ability to rewire itself based on new experiences. It's how we learn things, it's how we form memories, and critically, it's how we can recover from mental health struggles by building new, healthier pathways in our brain.
And this clay analogy is just perfect. A brain with high plasticity is like soft clay. It's malleable, it can be reshaped. In depression, though, the brain can become rigid, kind of like hardened clay. It gets stuck in these loops of negative thought and just can't adapt. So the goal of any effective treatment, really, is to make that clay soft again.
So how do they actually measure something like plasticity? Well, using that same tap and echo method, they can look at really specific biological markers in the brain's response. For instance, they can measure how strong the brain's braking system is, or how fast it processes information. By looking at these things together, they can build a really clear picture of the brain's ability to change.
And this brings us to the second major finding. Just like with psychosis, the researchers found a direct biological connection. As patients started to feel better on their antidepressants, their TMS EEG readings showed a clear, measurable increase in plasticity. The hardened clay was literally becoming soft again, ready to build new, healthier patterns.
So what happens when we put these two incredible findings together? We get a really powerful glimpse into the future of psychiatry, a move away from guesswork and towards data-driven care.
So we now have these clear biological signatures that tell us if a treatment is working. For psychosis, a positive response is marked by an increase in brain complexity. Simple as that.
And for depression, it's marked by an increase in brain plasticity. These two simple equations, they could totally revolutionize how we approach treating these conditions.
The potential here is just enormous. Imagine a world where doctors can use objective brain data to see if a treatment is working within a matter of weeks, not months. This means we could finally shorten that painful trial and error period and start tailoring treatments directly to an individual's unique brain biology. That's the dream, right? That is the definition of personalized medicine.
And that leaves us with a pretty powerful final thought. For decades, we've watched other fields, like cardiology, develop these incredibly precise diagnostic tools. Well, this research suggests that psychiatry might finally be on the verge of its own data revolution, building a future where treating the brain is every bit as precise and personalized as treating the heart.